Let me just double check that. Yes, it's recording. Okay. Yeah, so between Monday and Wednesday, you were trying to sort of take whatever physical prototype you had and try to model it, right? Yeah, so I'm going to go through a couple of step-by-steps that might help you with that. It's being recorded. I'll post it as soon as I get a chance after class. It's really just sort of waiting on YouTube to process things and upload things. Yeah, anyway, this is to take you through the weekend, right? I'd like you to try your best to actually build that grasshopper model, right? That grasshopper graph, model this thing as a parametric sort of component. Okay. I'm going to show you one. I'm going to show you the sort of two-faced pyramid, right, that I said you can't do. So I won't take up yet another one that you can't do. I'll go ahead and do that today in front of you, but we'll talk about how to begin to approach these step by step, okay? All right. Just as a reminder, on Monday when Kyle went over things, I added a couple of links and tips that he gave here if you need to refer back to them later. And let me just get Rhino started here. Hopefully, there we go. Right. So eventually we're going to take a large surface and break it up into small surfaces. Populate those small surfaces, right, like a checkerboard. Populate each cell with your shading components. Well, let's just start with one, right? So that's the goal for this weekend, is get one working one. Then instead of giving it one quad to populate, give it a list of quads to populate, right? Okay. So the first thing I'm going to do quickly here is just generate a quad in Rhino, and I'll bring it in Grasshopper and start to do something with it later. So if I just look at this and say, oh, there's several different ways I can make a surface, right, from 3 or 4 corner points, or I could just sort of drag from one corner to the next. I'll do 3 or 4 corner points, just to reinforce the fact that this thing might not be a perfect square quad, right? It's a 4-sided thing. Oh, don't tell me this is not going to behave itself. Okay. Yeah, for some reason, something's going on here with my wireframe. All right. That's weird. I thought I had that fixed. Damn. Right, so I just made a planar surface, right? The door closed behind. I don't know if anybody can prop that open in case other late stragglers or latecomers. Thank you for doing that. All right. So as we mentioned before, right, this is our ingredient. Eventually, we're going to define some sort of shell shape. Then we're going to divide that shell up into a bunch of little quads just like this. So let's start with this as our ingredient, our first ingredient, right? Just like if we're baking cookies, we'd start with flour and vanilla extract and eggs and things like that, right? What we need here, we need a quad, right? A 4-sided thing, 4-sided polygonal surface. All right, so I'm just going to move Grasshopper over to the right here and try to keep a view of our quad on the left, right? So again, when we do things in Grasshopper, we're building a mind map for it. It's actually modeling these things for us right now and previewing what that stuff looks like. Okay, so in quite a dynamic view, we can change parameters, variables in Grasshopper, and everything sort of updates, flows from left to right. Everything, all the changes propagate on our screen in Rhino. Then we actually want a static version of whatever we have in Grasshopper. We can bake a static version back into Rhino, right? So let's start. First and foremost, I'm just going to bring this in as a surface, right? So I'm going to go to the Params tab and go to my geometry placeholders over here, right? This is the quickest way to sort of bring in something from Rhino, bring it in so I can reference it in Grasshopper and start to build off of it in parametric graph, right? So in this case, I have a surface. So that's why I picked surface. And there it is. I'm going to say right-click, set one surface. Grasshopper disappears, allowing me to select a piece of geometry in line. Right? It expects me to pick one surface, which I'll do. Now Grasshopper reappears. You can see the widget is no longer orange or grayed out. It's now looks normal. It's because it's receiving data. In fact, if I hold it over, it says, oh, there's one reference surface from Rhino. Right there. Right? Okay, great. So, anybody remember the next step? I went over this once or twice and gave you an example, but I don't expect you to remember. But just curious if you remember. What do I want to get out of this quad?
You want to divide the surface, right?
Well, no. This is our ingredient, right? Like if we divided the surface up into quads, this would be what we are using, right? Quad. So what do we need from this? Yeah, we need to sort of place points and start connecting dots again, right? So everything we did in project 1 matters, right? Okay. All right, so what I'm going to do is I'm going to explode this. What I want to do is I want to find the face of this quad. I want to find the edges of this quad, curves, lines, whatever they are, right? And I want to find the vertices of this quad, right? Okay, so if I go to surfaces, right, I have a surface. And let's say I want to blow up a surface. I can deconstruct a B-rep, right, which is a fancy word for polysurface or surface. And I can plug that in, right? And what do I get out? I get the face, the edges, and the vertices, right? Since this is a quad, I have one face, I have 4 edges, not a big surprise, right? That's the definition of a quad, and 4 vertices, right? Again, not a surprise. All right. So now what? This becomes really important, right? This is what you've been working on with your pieces of paper. I have a quad, right? And I just told myself I have, this is an edge, this is an edge, this is an edge, and this is an edge, and then this is a point, this is a point, this is a point, this is a point. Now, and then also I have this face, right? Which is just a little surface. If I'm thinking about what I'm going to model, but you can't model, right? Just sort of 2 sides of a pyramid, I can immediately identify this vertex, and this vertex is really important, right? In other words, here's one edge of a triangle, here's another edge of a triangle. Those triangles are going to come up to a point up here at apex, right, the top of the pyramid. And so now what do I need to do? I also need to identify some sort of point along the face and project it up in the normal direction, and then I can connect the dots with some triangular surfaces, okay? All right. Now that's one way to do it. Let's say I wanted to do it a different way. Let's say I only wanted the triangle to come, I wanted to be able to sort of adjust the triangle length along this edge and this edge, right? Instead of using this vertex and this vertex, what can I do? I could evaluate one of these edges, the lines, right, the curve, with a T parameter. And with a slider, then I can start to adjust this back and forth and draw something that's more responsive, right? So let's talk about this. But it all starts right here, right? If you can draw it, sketch it, then you know exactly what you need to do, right? How to break down the initial ingredients into a bunch of ingredients that then we can actually start. All right, so first and foremost, we know we're going to use some of these vertices, right? And I have a list of 4 of them. Not a surprise, right? Now I want to have a list with just the first one and the second one and third one and fourth one. I want to start to separate them out, right? So I can connect, let's say, the first one with the third one, and then another point and make a triangle, right? Or for instance. Okay, so let's do that. This is a list. So if I go to the Sets tab, right, I can go all to the List tools over here on the left. There's all kinds of things I can do with lists, right? We talked about this a long time ago. Way back like in week 2 or something, right? We can, we have a list of objects, we can reverse it, we can sort them, we can shift them, right? We shifted the list. We can extract a smaller part of the list from a larger list. We can actually just pull out one single item from that list. It's called list item. there's a variable called in, right? It's the second one down, list item, right there. This one, right here. Retrieve a specific item from a list. We're always going to have 4 vertices because we're always using quads, right? So we can just make 4 of these widgets, one for the first vertex, one for the second vertex, I'll just copy and paste, the third vertex, and then the fourth vertex. Right. Now, how do I tell it which one I want? If I hold my cursor over the index number, the first one is set to 0, right? That's the first item in the list. And so if I hold my cursor over this list, actually, let me just give you a notepad so you can see these in real time here. All right. First of all, it stores points by an x, y, and z coordinate, right? So we have negative 23.30797, comma, an x, and then negative 7.583656 in the y, and then 0 and z. All right. So this one's giving us, oh yeah, that first one, negative 23.30797, negative 7, blah, 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 right? What if we want the second one? Oh, look at this list, by the way, right? It's numerated. Just like if you were making an outline in Word, right? Except instead of starting at 1, it starts at 0. My computers count starting at 0. It's really annoying. So the first item is number 0. The second item is number 1. The third item is number 2. The fourth item is number 3. And so what we're going to do is for each of these, we're just going to, I want the second item, so I'm going to tell it the second item. It's number 1, right? The third item is number 2. And the fourth item is number 3. Welcome to one of the weird paradoxes of trying to script things with computers. All right, so if you want to leverage computation, that's one handy thing to remember, right? They start counting at 0, and darn if it's really annoying because it's counterintuitive to the way our brains think. Although it does make sense when you play these things out, it's their most logical conclusion. So there's a reason for it. Okay, and so look at this one. This one is the second one now, right? Negative 21.44686, comma, 26.97374, blah, 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 blah. That's the third one, that's the fourth one, right? If you don't believe me, I will select this. You can see that that one's being selected now. That's green. And then that's the second one. That's the third one. And that's the fourth one, right? Okay. So what we said is that we want the second and the third to form one side of our triangle. And we want the second and third. The third and the fourth to form another side of the triangle, right? But what do we really need? Three vertices to a triangle, right? Yeah. Right, so we need this point. And we can generate this point by placing the point on the surface. Right? It gives us the location on that surface, it gives us the normal direction of that surface, it gives us the perpendicular plane of that surface at that point, right? Okay. So here's what we're gonna do. We're gonna take this face, right? And go to the surface tools, right? Let's evaluate the surface of a UV parameter. We're going to place a point along that surface. How do we do that? In Rhino, we turn on object snaps, right? And we can find the midpoint, the center point, the quad, the vertex, the endpoints, whatever they are, right? Here, what we can do is we can plug in the surface. I'm going to go ahead and say reparameterize, right? In other words, I want the U direction to go from 0 to 1, and the V direction to go from 0 to 1. Now I can plug in a multidimensional slider. Ah, and there's our point. And our perpendicular frame, right? I can move this around all willy-nilly. All right. Now, what did I say we need to do? We need to actually project up perpendicular to the surface, right? Yeah, you were just doing it. So let's draw a line. We have a start point. We have a direction, right? That perpendicular direction. We can give it a length, right? So line by SDL. You didn't know there were so many different ways to make lines, did you? There are. Start point, right? Here's the normal direction, N for normal. I'll give that as a direction. Why does that make a difference? if these 4 points, in fact, it's a real fluke that all 4 of these points are in the same plane, right? If you think about all the possible 4-point combinations of 4 points, only a limited number of them actually fall all in the same plane. So it's not necessarily guaranteed that this thing is planar, could be twisted. It could not simply not be on the XY plane, right? It could be on a different plane, even if it was planar, right? So what we want to do is we're going to connect it to, we're already sampling not only the location of that UV coordinate, right? But also the normal direction of the surface of that plane. Let's use that, right? So that way, in case we change the orientation of this darn thing, it's always going to be perpendicular, right? All right, and then a length. So here we go. That's a variable, right? That's like how many cups of sugar, how many morsels in the Tool House cookie recipe or whatever it is. All right, and so let's see. I'll go ahead and plug that in. I'm going to change the min max here to something maybe a little that. Yeah, let me try that again. There we are, somewhere. Now look at this. For whatever reason, our surface is flipped. I could go in and try to like change the surface direction. Or yeah, I could just simply change the length, right, to a negative. So what I'm going to do first is I'm just going to give us the flexibility, and I'll go -10 to 10. And now I can go the other direction and make sure everything's working. Yeah, very good. All right. We are really ready now. You want to connect these points? Start making a little half of a pyramid or something? Yeah. All right. Cool. Now, after that, then we'll start to build in some more stuff to it, right? More bells and whistles. A lot of you are doing things that are more complicated than just 2 triangles, right? So we can talk about how you can start to derive more of these sorts of geometries. All right, so, but first, let's connect the things up with triangular surfaces. So we're going to make surfaces, and I'm going to go to surface. That makes sense, right? And if I go to freeform, there's a 4-point surface that's create a surface connecting 3 or 4 point points. That's exactly what we want to do, isn't it? We want to connect up 3 points into a triangular surface. I know it says 4-point surface, but technically when you hold your cursor over it says 3 or 4 points will work. And so that's what I'm going to do. Let's look at this. This is the first vertex. This is the second. So I'm going to plug in the second for A. Yeah. And then I'm going to plug in the third for B, and then the top for C. Okay. Now what is it doing? How do I fix this? You notice that when something turns red, there's usually a message right here, right? So it says data conversion failed from line to point. What is it talking about? What step did I miss? Yeah. I'm plugging in a line when it's actually asking for a point, right? What I want is the end point of this line that I drew, right? Very good. And so that's what I'll do. I'll say, okay, I have a curve. Let's query and look at the ingredients that make up this curve. There's 2 points at least, one at either end. So let's find endpoints of this line that we drew. There's a start and there's an end. I'll plug in the endpoint for C. Oh. For C, not D. There we go. All right. Now we have, voila. Yeah. I'm going to change the minimum maximum. I maybe want to make this a little steeper, or have the ability to if I want to later. So I'll go -30 to 30. And that way I can sort of hike this thing up and make it really spiky if I want to. All right. Great. That height becomes really important, right? Yeah, I mean, aesthetically, from a safety standpoint, materially, how it might perform, how it might shade or provide shade or open things up more, right? Okay, so remember that at some point we might actually replace this slider with some actual data, right, informed from, let's say, solar data. But for now, let's just start simple. All right, so there's one triangle, and now let's make the other triangle. Surface. Surface, 4-point surface. We'll use this vertex, vertex 3, vertex 4, and the endpoint from our apex point. There we go. All right. Yeah. And now if you'll remember, We can move this around, right? We can adjust this in either direction or both directions, woohoo, right? And also, remember, if we modify this original surface or change the surface, read it, right? Then we'll populate a different quad. Yeah. All right, so let me just try to demonstrate that. Let me see if I can turn on the points for these lines here. Yeah, it's just not going to work. Darn it. It's my video card. But if I change this, let's say, and made a different surface, or I moved the surface around, right? Let's rotate it actually, so it's out of plane. Yeah, this thing's going to project perpendicular to that surface still, no matter how I turn that surface, no matter what surface I give it. All right. So that's what I'm asking you guys to do. Some of you have some very complicated components, right? And I'm not saying that the easiest thing is always the best thing to do. Don't get me wrong. I like really interesting things and complex things. But I think there's probably going to be, some of you are going a little too simple, and some of you are going way too complex. Particularly if you think about these being scaled downwards, making all those intricate folds, right? So you might have to find a sweet spot, right, between what's really helpful and what you can actually make, right? The manufacturability part and the scale part are going to inform and maybe make you up the complexity or scale back the complexity a little bit, what you're thinking with your piece of paper out here at this size, right? But suffice to say, we can start to build off of this and make much more complex things. Let's say, like before when I was drawing, let's say I want, instead of using vertex 3 and vertex 4, let's say I want that point to be something that can run along the edge, right? Okay, so what I'm identifying is the A inputs for each of these, right? All right, so I'm going to replace those with something different. In this case, I need to look at the edges, right? Because I'm going to be building points along those edges and then moving the points along those edges, right? So what I need to do, the same thing I did here for vertices, I'm going to make another set of them, and I'm going to do the same thing for the edges. So I'm just going to replace the input with edges down here. I just copied and pasted this. If it helps, be here in the moment and ask good questions, because I'm recording this. So you can always go back and ask what I'm doing later on to see the nuances. Like, where did you get those for? I wasn't paying attention. I copied and pasted them from the ones up above, right? Okay, but you can always go back to the video. So anyway, so now here we have a line-like curve, a line-like curve, a line-like curve, a line-like curve. All right, so in fact, there's the first one, it's green right there. There's a second one that's turned green. There's a third one that's turned green, right? And we're going to be looking at this one and this one. So if I take these curves and again, things that we've already done before when we're building trusses, you guys got really good at this. Evaluate the curve at a t parameter. I'm going to evaluate this one. I'm going to right click and say reparameterize. That way the start is 0, the end is 1. And now I can use a pretty generic slider to control a point along that edge, right? Oh, sorry, I'm being very careless about sort of connecting things up. There we go. Yeah, here we go. And now I can start to change this. And now if I switch this out, right? Now I can also modify that. Yeah. You see how this lines up with that? You know why, now you see why I drew it just like that? Yeah, right? Again, all the skills you have and learned over the last couple of years, they're not mutually exclusive and then going digital, right? They help you, right? The digital stuff just augments that. Okay. All right, so I can do the same thing. I can make a copy. I'm going to leave the same t parameter plugged in. That way I can adjust both of them with one stroke here. I'm going to plug in this edge, and I'll replace the right A input. Oh, sorry. The B input for this one. Okay, there we are. And there we have it. Right? Now, this is interesting, right? you can see that this is the start and this is the end for that line. This is the start, this is the end for that line. Right? What I want to do is actually move it from this point inwards, just like this one. Right? You can see it's doing the exact opposite here. Right? All right, so I either look at that and go, that's actually a feature rather than a bug. I really kind of like that. I didn't think of it that way. Or you could say, no, the way I drew it, that's what I want, right? So let's fix it if I wanted to do that. Now, let's say I adjust this over to point 2, right? Can you guys see that?
Yes, sir.
So we're 0.2 over this direction, we're 0.2 over this direction. This is 0.8, right? In other words, this is always going to be 1 minus whatever this is. Yeah. So that's simply what I'm going to do. As I adjust this, I want to plug it in directly to this t, and for this t, I want to subtract it from 1 and then plug the result in. So if I go to math, I can do that. I can say, whatever this number is, I'll subtract it from, I'll right click and I'll say the first item is going to be 1. Right? So now I'm always going to get if this is 0.2 going in, 1 minus 0.2 is 0.8, right? Yeah. And so then I'll just plug that in for t. Yeah. Now we have something that worked how I drew it. Yeah. Okay. You can see that I have all this construction geometry here. I have points, planes, lines going off in the normal direction, and things like that, right? At a certain point, this starts to build up, right? Sure does. And so there's certain things we can do. Also, we start to get visual noise over here. Sometimes it's helpful, but other times, it starts to get too busy for us to really understand what's going on, right? So let's talk about the graph and how we can sort of keep things nice and clean. First and foremost, if you're into using Control G, right, that's how you can group things. So in Grasshopper, you can start to group these things together. For instance, you could say, well, here are really just the parameters, right? And I could sort of group them off over here together. And, here's the initial ingredient. I'm just going to put that way over on the left, right? The other thing you can do, if that helps, if that doesn't help, there's other ways to sort of organize this stuff, right? Don't be afraid of using your space here, your canvas, to sort of move things away from each other, right? So here we're exploding the surface. One of the things I can do, and this is often what you find when you're looking at code, you'll write like comments inside the code to sort of help you sort of wayfinding devices, right? So in this case, I can always go to the params tab, look for that panel, that notepad widget, and put one over here and say, exploded vertices from quad, right? And then down here I could say, well, these are the exploded edges from the quad, right? I mean, sometimes it just helps. Sort of keep these things organized, pull them apart, right? There's nothing worse than we look at something and go, oh, that's a big jumble of spaghetti. I can't even figure out where things are attached, right? So use the space accordingly. You can always select these things even and start to align them in columns and rows, right? You can even have them evenly spaced between if you want, right? In order to sort of add some clarity, right? So here we have vertices. These are all just sort of ingredients from the quad. Here's the face that we're pulling a point from, right? Here's really the end ingredients, right? The end results. Those are the actual surfaces that I need to sort of unfold and laser cut and fold back, right? Okay. Can I add, I noticed some of you have this situation. Can I add another fold maybe? Can we talk about that? How you might go about adding more folds into this thing? Because a lot of you have more complex things than this. Yeah, right? But what you need to do is you need to be able to build off of either the face, the edges, or the vertices of the quad. Or any combination thereof. And if you can do that, you can build anything. If it gets really heavy, you just need lots more computation, like, a faster processor, but it'll still work. All right, so let me just straighten these up. Okay, let me just save. How many of you have gotten in the habit now of saving regularly? You should, if you don't. I'm going to call this 367 project 2 junk delete me later, right? Because I just, later on I'll go through and is this important? I'll be like, no. Yeah. All right. So, let's say I wanted to add another crease right here, right? Somewhere in between. First of all, we need to look at whatever this dimension is, right? And identify some sort of, point in between, right? So that's one way of thinking about it. Let's try it. What I'm going to do is I'm going to make a couple more copies of these, or I'm going to make more points along those edges. Now we're going to do some funky things with these t parameters. So instead of feeding the direct t parameter in, I'm going to feed its the result of simple arithmetic, subtracting it from 1 in for this one. And I'll get something that's actually that far in the other direction. All right. And I'll plug in the original one for this one. Yeah. Really weird, huh? Now they're all linked up, so if I start to make changes here, that's probably the one thing I don't want, right, is 0.5. In fact, what I'd probably do then is change the minimum maximum, so it can only go from 0 to 0.499. Right? I can always constrain it that way, so I never actually have something that doesn't quite work, right? I always have some sort of fold. What I'd probably do is maybe even change that to something even more useful, 0.35, let's say. There we go. Now I'm always going to have, some wiggle room here. All right. And now what do we need to do? We have these points, but let's say we want to fold this inward. So we actually want to project that point into the surface a little bit, and this one into the surface, right? Yeah. All right, so let's try. Whoa. All right, let's try that. There's probably more than one way to do this. But if I simply take this point, and let's go to surface, let's see what I can do here. If I want to get the isoparms of a surface, let's see. You'd think it'd be here, right? Oh, maybe it's under curves. It sure is. Isocurve of a surface, yeah. All right, sorry, it's in curves because you're getting curves. So what I want to do is I want to actually find, again, that latitude and longitude line for each of these points. Okay. So I want the latitude line for this point, right? And I want the longitude line for that point. Yeah. So let's try that. And let's see what happens here. It needs a surface, it needs a UV. Oh, that's going to be more difficult than I thought. What would be a good way of doing that? Yeah, let's try it. Why not? Okay, sorry. I'm just thinking to myself, like, should I go through the pain and suffering? Yeah, sure, why not? Okay. What I'm going to do is I'm actually going to use this coordinate, this t value. I'm going to string them together to make a UV coordinate. So that way I get that line and that line. So I know this t is this. I know this t is that. Yeah. All right. Now, the way to put those together, the simplest way is to actually plug those into a point widget of all things. And then I'll disregard the z being 0, which is kind of weird and annoying, but it is what it is. Let's just rip off the Band-Aid and use it anyway. Here we go. All right, so now you'll see I have a point that says 0.749, 0.251. They're separated by commas, and I'll disregard that third value when I plug this in for a UV coordinate. And then what do I need to do? I need to plug in this original quad, or the face of it. I also need to make sure that's reparameterized. You gotta be kidding me. All right, so sorry, it's probably back here, this one. So I gotta rearrange the order of these things. So you see what it's doing, right? Yeah, that's just super. All right, so what's this point over here? Let's see. It's this one. And right now we're using the same t value that I have plugged in there for the other version. Okay. Let's see, what do I have here? 0.749, 0.749. Wait, same one? No. Okay, sorry. So I'm either going to do this the wrong way or the right way. Okay, the wrong way it is. All right, so I want the 0.749 plugged in. Let's see, which one's that? That one. Okay, so I'm going to put 0.749, 0.749 on each one. All right. There we go. Sometimes my brain doesn't work so much, especially around 10:30 in the morning. All right, so yeah. Now what I can do is I can find that point. I have this line, right? I have a U and a V. Oh, heck yeah. So now what I can do is I can place a point along this and place a point along that, and then replace, or actually add another triangle or two, right? So what I'm going to do is I'm going to get rid of these for the time being. I'm just going to turn them off. So I'm going to select them. I'm going to say solution. I'm going to say preview selected off. There we are. Okay. And let me just draw this out. Let me highlight this in green so you can see it, right? So now, thank goodness there's an actual marker. Now I have a point here, 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 and a point here, and then something also somewhere up here, right? Okay, and so now I'm making something that there's a line there and a line there. I'm actually going to make a point in here and a point here. Then I can start to make a triangle from here to here to there. And then from here to there to there. And then from here to there to there, from here to there to there, right? Yeah, all right. So let's try this. So what we're going to do is we're going to take these two lines, a U line and a V line, right? And we're going to place another point along them using a T parameter. Yeah, all right. Woo-wee, right? So, again, nothing we haven't done before. Does it help sometimes to just strictly sketch it out on a napkin in front next to you? Yes, it definitely does. Heck yeah, it does. All right. All right, so let's see. Parameter. Evaluate curve at a T parameter. So we'll go with this one first. We'll reparameterize it. So it goes from 0 to 1. And then let's see where the 0 and the 1 actually lie. There we go. Now let's do the same thing for the V. Oh wow, that actually worked better than I thought it would. All right. Yeah. All right. And so now it's about connecting the right dots. Right, so we have this one. Oh, now I have to really think about this. Ay. All right, I'm going to go ahead and turn that preview off on these because they aren't needed. They were just construction geometry. We have this one, and we have this one, right? So this one, to then this top one. Yeah. Ay. Okay, so surface, triangle.
4-point surface. So we have this one. Let's see, there it is, right there. A. Then we have this new one that we made. And then for that top, we're going to get that endpoint. It's all the way up here for some stupid reason, because I put it up there. I'll blame myself later. Right. Yeah, all right, look at that. Now, we're going to have, instead of 2 triangles, we're going to have 4 triangles, right? Because we have a number of folds to sort of negotiate here. Yeah. So let's see, here's another one. And another one. I mean, I can tell you're going to have 4, so let's just put them in. All right, so this B, okay, this will be here, right? And then we need this vertex. That's vertex 2, vertex 3. All right, so that's vertex 3 over here. And then we also need the height one. So we're just connecting the dots. Now we have a fold, a side that actually folds inwards. Pretty sweet, huh? I can tell you guys are enthused by your loudness. Or something, I don't know. So anyway, yeah, and you can begin to sort of play around with this thing, right? Just like you do with paper. Yeah. All right, so now we just need to do the same thing over here, right? So we'll use vertex number 3, then this point over here, and then the height. So that would be this point for B, vertex number 3 for A. And if I too far away, I can always move this around and get it close to the input I need, then move it right back. Oh yeah, look at that. Okay, and then the last one. You guys ready for the last one?
Yes!
Thank you. That was so not scripted. My new pair of pants after that. All right, so thank you. I love your enthusiasm. Let's see, endpoint. There we are. All right, so again, this whole thing is responsive and, so again, it's all about going back to all the things that you've learned and done previously anyway, right? Where's that height? There it is. Yeah. All right. Let's see. Yeah. All right. That's it. Connecting the dots again. And now you're building points off of other points, points off of edges, points off of faces. What were some of those key things? It all comes back to this. Remember, our ingredient is that quad. It has one face, right? 4 edges, 4 vertices. You can separate the first, second, third, fourth vertices away from each other, first, second, third, fourth edges away from each other. It's back to building trusses, right? Hopefully that starts to make sense, right? Okay, now, there's a few other things here that I should mention, and this is going to happen next week, right? You get to this point and you say, okay, what happens if I plug in a list of quads instead of just one quad, right? Well, what you're going to do is you're going to start generating lots of data trees. And then you might break a few things downstream, then you have to sort of figure out, well, where do I have a list being plugged into an input? And a similar input, I have a data tree. And then do I need to make the data tree a list, so the list is matching up with the list? Or do I need to make the list a data tree, so the data tree is matching up with the data tree? I know it sounds weird. It's actually not too complicated if you can, again, you can keep this organized, so it's like a flow chart that you can actually read, then I can help you with it, all right? So, let me just demonstrate this for a second. Let me save, because this is about to get computationally intensive, but if I took this surface and instead of using it as my initial quad, let's say I break it up into a series of quads, right? just like we're going to be doing with our grid shell. Let me go to math, and I'll say, let's divide this two-dimensional domain. Let's measure it. Let's tell it how many divisions we want. We don't want 0.25 divisions. We want them to be integers. We don't want to divide by 0. So I'll go from 1 to 10. And then I can take a surface and I can make a surface from isotrim. Here's the list of domains. Here's the surface. Now I get a series of surfaces. All right. So many surfaces. I'll even turn this off just so you can see it a little easier. Right, so let me actually set this to something a little less heavy. Let's just go two by two for now, and then I can always amp it up later. But if I plug this in for now, what I'm doing back here, right? Let's just do that. Oh, hot damn, it actually just worked. Yeah, right. Sometimes it's great when that happens. Holy smokes, right? So what is it doing? Look, now instead of having one face, I have 4 faces, but they're not actually just a list of 4 faces. It's a data tree. Here's a branch, here's a second branch, third branch, fourth branch. Each branch has one quad in it, right? All right, so from there I can begin to sort of change these things around, do whatever. Yeah. Let me just double check, do spot check here. Doesn't look like anything really broke. I'm strangely surprised, oddly surprised by that. And so then I could actually, change this, right? -10 looks really kind of weird now, but yeah, okay. Also next week, after you start to pick out how many divisions you want in the U and the V, we can actually generate our rib system as well. It's structure underneath that forms all these quads. Yeah, so you see how we're sort of reducing this into small problems? You start with designing a component, right? Then it's about how you make it parametric and variable. Then it's about how we can repeat it over and over again. Then later it's about how we add structure to it. Then it's about how we measure its performance and then begin to revise it based on the performance. Then we prototype it. We figure out what kind of changes we need to make in order to be able to make it out of with the laser manufacturing and chipboard of all things, right? Yeah. So it actually becomes quite complex. It doesn't have to be complex to start with. You build the complexity into it, right? By complexity, I mean how many different competing concerns and constraints can actually respond to. That's what complexity, good complexity is, right? So, make sense? Capiche? All right, cool. How are we doing on time? We're doing excellent on time. Here in a minute, I'll open up for questions. After the questions, I'll turn off the recording so that and I'll get it going, uploading to YouTube right here now. Then I can float around and I can start addressing any individual questions as best as I can during class time, okay? Yeah, what was the question?
I was just wondering what that widget is. You attach a circuit to this and
This one? This one right here? Yeah, that's an interesting question, right? So what this does is it divides a two-dimensional domain. Let me go over to the board here. Sometimes it's helpful to sort of see it. Yeah. What's that?
Something happened.
Oh, that's your computer? Uh-oh. Yeah, that was like the processor fan going off. I think it was going to blast off to space or something. All right, let it sit for a minute, let that remain clear out, then go ahead and restart. Did you try to do that first part? And suddenly like exponentially grew, or did you get something orange? All right, we're talking about domains. A domain is just a simple way of saying any space between a minimum and maximum, right? So a domain might be 0 to 1. That's a good one. Each of these at a loss, right? In fact, that's how we define the minimum maximum for a number slider, right? Just a domain. You can have any value inside that domain, right? Equal than or greater than, equal to or greater than 0, less than or equal to 1. Anyway, that just drives my brain mad. 0 to 1, right? So you can have a two-dimensional domain. A two-dimensional domain would be 0 to 1 and 0 to 1, just like a surface, right? Here's a line, a curve, there's a surface. So if you think about a spreadsheet, right? Sometimes, how many of you have printed a spreadsheet before? You had to print a spreadsheet, like in Excel or Google Docs. And you didn't want the whole thing, so you actually selected, this column or this cell all the way down to this cell. You were defining a two-dimensional domain. You were saying I want everything between B2 and Q19, right? And so it said everything between B to Q and between 3 and 19, right? That's what this is. You can actually figure out what the surface two-dimensional domain is. It might be 0 to, might be some random, might have to do with the units in Rhino. It might be 22.94, blah, 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 13. Doesn't matter. But we're going to tell us how many times we're going to divide it. How many columns, like a spreadsheet, and how many rows we want to divide that domain in. And so let's look at what comes out, right? I'm dividing something. Let's look and see what we plugged in. We plugged in the surface, and it's telling me that the domain of the surface is 0 to 30. It's easier to read it up here. 35.915828. That's why when we plug it in later, we reparameterize it, so it just goes from 0 to 1 really nicely. Yeah. And V goes from 0 to 42.99, blah, 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 blah. And we're going to say, let's divide between 0 to 35, 36, let's say, 6 times, and between 0 to 42, 6 times. And so it's going to give us out a big long list of stuff. So not only is it going to go in this direction, but it's also going to give us everything because it's a two-dimensional domain. So it's going to give us 0 to 5.98, 0 to 7.1. These are all going to stay the same. These are going to step up. Then this is going to step up to the next one and step up in the V continuously. Right? We're going to get basically, in this case, 6 by 6. We're going to get 36 outputs. And that's what it actually says, 36 locally defined values, right? Then we plug those in and say, this is, I can just pick one simple domain, right? One portion, one quad inside the surface by giving it a minimum and a maximum longitude, minimum, maximum latitude. Except instead of giving it one, we're giving it a list of those. And so now we get to check them. So we get a series of cells and columns and rows. That's the logic behind it. All right? I don't know if that makes sense to you or not, but that's the way it works. And so anyway, that's what's happening. That was a very good question. Yeah. We'll talk more about that next week. I don't expect you to do this front part next week. Get it working in one cell. You can try this afterwards, but what do you want to do? Save and then save as, so that way if you accidentally screw something up big time, right? You didn't just screw up the whole thing you were working on an hour ahead of before. Yeah. All right. Okay, great. Yeah, so now we have a responsive component. And, I didn't do a fantastic job of keeping things organized, but I could maybe do a little more thorough of a job here. Yeah, all right. I could add notes, I could sort of comment on things, keep things separated out. Right, you have a big, large canvas, so you can utilize it if you want to keep things organized. Some of you, I can tell, your studio space, your rooms at home, they're all probably pretty organized.
Yeah.
And others, not so much, right? It's the same way here. Any other questions before I turn off the recording, get that uploading, and I can float around? All right, then let's get to work. That was a healthy